My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 69. In this lecture, I will explain about median briefly so that in lecture number 70, that is in my next lecture, I will take a data set from Kaggle database, height weight data set. On that particular data set, we will try to apply mean and median, and we will try to construct corresponding histograms. Anyway, let me proceed further. First, before understanding the definition of median or properties of median, let me explain with simple examples. Let me say this is my data set or elements 60, 20, 10, 40, 50, 30. Now my intention is I have to find median. In order to find median, first arrange them in particular order, either in increasing order or in decreasing order. Usually we used to keep in increasing order. Therefore, what we did, just we are arranging elements in increasing order 10, 20, 30, 40, 50, 60. Isn't it? How many numbers are there? 1, 2, 3, 4, 5, 6 even numbers. Even numbers of data points is average of middle 2 points. What does it mean? What are the two middle points here? Just see here, 30 and 40 are middle points. This one average of two middle points. Therefore, 30 plus 40 by 2, that is 70 by 2 means 35. It is simple and elementary class mathematics, nothing more than that, isn't it? Anyway, let me proceed further. We will try to understand impact of outliers. What is this impact of outliers? Just let me consider this is my data. Actually, this is my data. And which one is outlier? I am adding 1000 as an outlier. Therefore, it is not in particular order. Just here we are arranging the data in particular order. I can say I arranged in ascending order. Now, how many numbers are there? There are odd numbers. Just see, odd number of data points means you will get middle point. How will you get? Just this side 3 elements, this side 3 elements. Middle element is 40. Simply I can say 40 is the middle point, as this 1000 is an outlier. We will try to understand how outliers affect this median and mean in lecture number 70 or in 71. Maybe I may not, it may not possible to discuss in 70. I will try to discuss in lecture number 71. Time being, let me proceed further. Yes, middle value. What is median? One can say it's middle value in which array? It's an ordered array of numbers. That's important. In an ordered array, that middle value is known as median. It is applicable for ordinal data. What is ordinal data? In last lecture also, maybe I think lecture number 67, I discussed what is ordinal data. For example, product satisfaction. What is product satisfaction? They may say satisfied, or they may say unsatisfied, they may say neutral, isn't it? Even I can say faculty ranking. Faculty ranking means professor, associate professor, assistant professor. That comes under ordinal category. Even you can say student grades, A grade, B grade, C grade. Those are comes under ordinal category on which you can apply median. Even interval data means in last lecture also, I mean maybe in lecture number 68 I explained. If I say 2000 comma 2020, this is interval data, isn't it? This means on this type of data also you can apply median. And ratio means what? Weight, age, salaries. It can be expressed in points, 10.5, 3.4, something. Those are known as ratio data. Means it is applicable. Median is applicable on ordinal data, interval data, and also on ratio data. It is not applicable for nominal data. We already discussed what is nominal data, maybe in lecture number 67, isn't it? What is nominal data? What does it mean? Nominal data means I can say its simple example is gender. What is gender? Gender means maybe male, female. That is a nominal data, isn't it? I cannot apply median in between male and female, isn't it? In similar manner, I can say marital status. That I cannot calculate median for marital status. Marital status means that may be yes, that may be no, isn't it? It's something like that. Yes, it is unaffected by extremely large and extremely small values. Means it is not sensitive to the outliers, whereas your arithmetic mean is sensitive to outliers. How it is, we will try to understand with simple examples. Even I will discuss in future lectures. Maybe in lecture number 71 we will try to understand with simple Python programs, with simple Python code. Anyway, let me proceed further. Again, let me consider this example with an odd number of terms. Here, how many terms? Just count this. There are 17 terms. 17 terms means there are odd number of terms. What you have to do? Odd number of terms means your position of median. You can also calculate median position, n plus 1 by 2. 17 plus 1, 18 by 2 means 9th position. First position, second, third, fourth, fifth, sixth, seventh, eighth, ninth. This is 9th position. Means 15th is middlemost element, isn't it? As we were saying that median will not affected by outliers, isn't it? For example, in the place of 22, if I write 100, or if I write 1000, if I write 1 crore also, still this middle element will not change. Still it is 15. Even in the place of 3, if I write some minus 103 or minus 1 crore also, middle remains same. Means middle is not sensitive, it is not affected by adding outliers. Anyway, in future lectures also we will try to understand. Time being, just let me proceed. Here it is even numbers. Even numbers means it's same logic. How can I find? There are 16 terms. Just count 16 terms means even number of elements. As I told you in my last slide, what we were saying that 16 plus 1, 17 by 2. 17 by 2 means what? It is 8.5. It means it's an element between 8th and 9th terms. What is your 8th term and what is your 8.5 means you must understand that it is a middle element of 8th term and 9th term. Just see first, second, third, fourth, fifth, sixth, seventh, eighth. 8th and 9th terms means what? 14 plus 15 by 2. 14 plus 15 by 2 means what? 29 by 2 means that is 14.5. That's what it says. Still, it is not sensitive to outliers. If the 21, this element is replaced by 100, still its median is 14.5. Even this 3 is replaced by minus 88, still median remains same. It is not sensitive to the outliers. Anyway, even you can find median for group data. How one can find median for group data? There is a formula. In elementary classes you might have learned capital L plus n by 2 minus CFP by F mid into W. Anyway, instead of discussing this formula, let me explain with simple problem. What it says, just see, it is simple and straightforward problem. Here I have what is this group data? This is one group, 20 under 30, 30 under 40. This is given frequency. This is my given frequency. This is also given frequency. This is also, all these are given frequencies, isn't it? 70 under 80. This one is the given problem, I can say, isn't it? In that case, what you have to do, it is simple and straightforward. Just add all the frequencies. If you add, you are getting 50. Then what you have to do, just find cumulative frequencies. How will you calculate cumulative frequency? Just keep 6, 6 plus 8, 24, 24 plus 11, 35, 35 plus 11, 46, 46 plus 3, plus 46 plus 3 means 49, 49 plus 1 means 50. This is, in this way I can calculate cumulative frequency. Next, what you have to do, you have to divide this n by 2, 50 by 2. 50 by 2 means 25. Where can I find this 25 in cumulative frequency? In between 24 and 35. This 24 and it is in between 24 and 35. Therefore, I can say this now I need what is my capital L. My capital is lower limit. Whose lower limit? Just see, as it is 25 is in between 24 and 30, 35. This 35 is known as middle class, isn't it? Middle frequency, otherwise just go there. Where will you go? Just go back and check what it says. There is something like L plus. What is my L? L means lower limit. Whose lower limit? Let me check. The lower limit of the median class. How can I get median class? Again, let me repeat. 50 by 2, 25. It is in between 24 and 35. Therefore, what you have to do, this 35 is median class cumulative frequency. This opposite to 35 in frequency, that is 11. That 11 is known as middle frequency, FMED. FMED means, just see here, frequency of the median class, isn't it? The FMED means frequency of median class. 11 is frequency of the median class. And this 40 is known as capital L. What is my capital L? The lower limit of the median class. Here this one is median class. How do you know this 40 under 50 is median class? It is corresponding to this, what is that? Median frequency. Therefore, this is median class. Capital L is lower limit of median class. That's what it says. Now it is straightforward. You know what is capital L. This is my capital L. Capital N by 2, you know what is capital N, 50 by 2 minus CFP, cumulative frequency. This is before just this 35. This is CFP. That is CFP is just above that median class corresponding cumulative frequency. This is CFP. And just it's a width means what? 30 minus 20, 40 minus 35. This is the width. You can understand. FMID I already explained. Median class frequency. This is median class frequency. Just go through this and understand this simple what is L, what is CFP, what is FMID, what is W, what is N. This is self-explanatory. Anybody can understand. This is simple lecture. Just go through it. Go through it. In my next lecture, that is in lecture number 70, we will try to understand this median and mean with the help of one sample file. We will try to analyze how this mean and median are related. If you work on same file, you can compare mean and median. Thank you very much.